Hello guys, today we're going to solve this Leetcode question which is power of 2, and in this question we are given an integer n and we need to return true if it is a power of 2, otherwise we need to return false. We know what is a power of 2, right? Power of 2 is 2, 2 power 0, power 1, 2 power 2, 2 power 3, power 4, whatever. 2 power 0 is 1, power 1 is 2, power 2 is 4, power 3 is 8, 2 power 4 is 16. We just need to identify, you know, we're just given a number n and we just need to identify if it is a power of 2 or not. Suppose if we are given a number 3, it's not a power of 2, right? Suppose if we are given a number 4, it's a power of 2. Suppose if we are given a number 5, it is not a power of 2. Suppose if we are given a number 14, it is also not a power of 2. Suppose if we are given a number 16, it is a power of 2, right? So we just need to identify that. So how are we going to do this? Now initially, as a brute force approach, we're gonna we're gonna have, suppose we are given an n as, let's say 32. 32 is a power of 2, right? Which is 2 power 5. Initially, we will have a number. Let's say this is yearly, let's say element. Usually it is 1. What we'll do is we'll just multiply it with 2. It will become 2. Then we'll check are these two equal or not. These two are not equal, right? Then again we'll multiply 2 with another 2. This will become 4. Again we'll check these two are equal or not. Again we'll multiply. This will become 8. They are not equal. This will become 16. These are not equal. And again we have 32. These are equal, right? So we're just multiplying in them one with twos. Initially 2 power 0, then 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5. If any one of these matches the given number, then it is a power of 2. Else, at most we can go until 31 iterations. Initially this is 0th iteration, this is first iteration, this is second, this is third, this is fourth, this is fifth. We can only go up to 2 power 31, right? After that, the integer limit will exceed, right? So that's why at most we can go till 31. So the time complexity will be order of 31, which will be equals to constant time, right? Space complexity is, since we are not using any additional space, the space complexity is order of 1. So let's try to code this up. This thing, this check is nothing but, we're just checking if it is a negative number. If it is a negative number, it cannot be a power of 2, right? So in a constraints, we are given that we can also be given as negative numbers as well. So if we are given a negative number, we'll just directly return false, right? And then, as I already said, we'll initialize our element with 1 and our I starts from 1, I goes till 31, I plus plus, and our element is equal to n, else our element will become element 2, right? That's it. Then um, will run fine, but this is not the most optimal approach. In an interview, the interviewer may ask us to, could you solve it without without loops or recursion, right? The interviewer might ask us to solve it without using any loops or recursions. How can we do that? So if you observe carefully, all the powers of 2, 1 is a power of 2, right? 2 is a power of 2. 4 is a power of 2. 8 is a power of 2. 16 is also a power of 2. 32 is also a power of 2. You write the binary representations of this, it will be 1. For 2 it will be 1 0. For 4 it will be 1 0 0. For 8 it will be 1 0 0 0. For 16 it will be 1, and for 32 it will be 0 0 0. Right? If you observe a pattern, there is only one bit which is set, right? Remaining all the bits are zeros. So this is the unique property of each power of 2. So what we can do is we can iterate through the bits of the number, and if the number of set bits is only 1, we can say that it is a power of 2. But there is an efficient way to solve this. The interviewer asked us to solve it without using loops. Even if you want to iterate over these bits, you want loops, right? So we can solve this without using loop by using the following technique, I might say. So what's the technique? If you observe carefully, we have let's take 16. The binary representation of 16 is 1 and 4 zeros, right? And if we take 15, what is the binary representation of 15? It is 1 1 1 1, and at the beginning it will be 0, right? And we'll do AND operation for these two. Will become 0 0 0 0 0, right? 1 and 0 is 0, 0 and 1 is 0, like that. And if you take 32, it is 1 0 0 0 0. And if you take 31, it will be 1 1 1 1 1, and at the beginning it will be 0. If you do AND of this, 0 0 0 0. So this is the what they call unique nature of powers of 2. Uh, when you suppose if we are having a n which is a power of 2, and we do an bitwise AND with the previous number of it, then we'll get 0. If we get a 0, it is a power of 2. This doesn't hold true for any of the numbers, any of the non powers of 2s. Let's suppose let's take 14 and 13. In the case of 14, it is 1 1 1 0, right? And in 13, it is 1 1 0 1. If we do AND of this, it will become 1 1 and 0 0, right? Which is greater than 0, which is not equal to 0. We take 7 and 6. 7 will be 1 1 1. 6 is 1 1 0, which will be 1 1 and 0, which is not equal to 0, right? So if we take any of the other numbers other than the powers of 2, we'll get a value which is greater than 0. For only the powers of 2 will get value which is equal to 0. So we can solve this following way. It return n minus 1 equal keep a bracket here. I submit this, submit fine, I guess. It does. Thank you guys. That's it for the video. Thank you for watching.